before, we have been talking about understanding direct proportions. Now, in section 5.4, we're going to be talking about inverse proportions. So in a direct proportion, you could take a table and you could set up so that the top over the bottom was equal to the next one, top over the bottom was equal to the next one, top over the bottom. And they would both be increasing, but in this case, in inverse, instead of both increasing, you are going to have one increasing while the other is decreasing. So for example, in the book example, we have one that looks like this. The 1 goes up to 2 and 3. The 120 goes down to 60 and 40. So we know already that they're not related directly, because 1 over 120 is not the same as 2 over 60. Is not the same as 3 over 40. But they can be inversely proportional. So some students want to share some card games so that each student gets the same number of cards. The table shows the relationship between the number of students, X, and the number of game cards each student gets, Y. So this is the number of students, and this is the game cards. So you can see the more students you have, the less game cards that each student gets. So one goes up and one goes down. Because the total number of game cards remains the same, the total number of game cards each student receives decreases as this increases. So we could say that each student receives an inversely proportional number of cards to the number of students. So if we could create a product of these two. Remember when it was direct, we said that our proportionality constant k was y over x. When it's inverse, we could say that the proportionality constant is a product, x times y. So here, we could say that the x and the y equals 1 times 120 equals 120. That's for this one. For this one, we could say that xy equals 2 times 60, which is equal to 120. Here, x times y equals 3 times 40. Put together, that equals 120. So we know our total number of cards is 120, because for each of these, the proportionality constant is 120. And it is the product. So for any two quantities that are inversely proportional, the products will be the same. So let's try an example. The table shows the time it takes T hours for N construction workers to pave a road. Tell whether T is inversely proportional to N. If so, find the constant of proportionality. So we're going to do the same thing we did up here with this table here. You don't have to draw the table, but we can draw the N times T, N times T, N times T, and we'll see the constant of proportionality. So the first k is going to equal 1 times 36, which equals 36. The next k is going to equal 2 times 18, which is going to equal 36. And the next k is going to equal 3 times 0.4, which is going to equal, 3 times 12, I was already looking at the next one, equals 36. So remember k, like up here, k is x times y. So those are the same, those are the same, those are the same. So this is just our n times our t. And they're all equal, they're all the same. So we could say inversely proportional constant is 36. Let's try another one. Again, we're going to make three constants. X times y, x times y, the next one is 2 times 1. Next one is 3 times 0.4. Okay, so now we could say, we're trying to tell whether the number of students it takes to put a jigsaw puzzle together and the time is inversely proportional. So these two are the same, but this one is not the same, therefore it is not inversely proportional. So we can't get a k because they're not all equal. Okay? Try this on guided practice 1 and 2. Oops. Now we're going to identify this from an equation before we did it from a story problem. So the two quantities, such as y and x, are inversely proportional. Their product is a constant value, so you can write an algebraic expression to relate them. Remember, we said from up here that k is equal to x and y. We could rewrite this equation so this is the same as writing y equals k over x, because we've just divided both sides by x. So remember these equations, you can use both with these factors when they are inversely proportional. In an example, we see we're going to identify an inverse proportion equation to find a constant proportionality. So here's the equation. It says 1/2 y is equal to 5 over x. Now, we're going to try to rewrite it as either this one or this one, so that we can figure out what is the constant proportionality and see if it's inverse. So how we can do that is we're going to pick one. I say this one's simple. Let's pick that one. Let's try to get x and y on the same side and see if it is equal to something. Okay? So to do that, first let's get rid of this one. So we're going to multiply both sides by 2. When we multiply both sides by 2, of course these cancel. That leaves us with y. We multiply this side by 2. That leaves us with 10 over x. Okay, now we've done that. We want to move this x to that side. So we can multiply by x. And so then, of course, these cancel. We have to multiply both sides by x. So now over here we get xy. Over here we get 10. So we could say, after this is simplified, that it is inversely proportional, and the constant of proportionality is 10. So if xy equals 10, we could say that k equals 10. And that is our constant of proportionality. Go ahead and try this in guided practice 3 and 4. And that is all for part 1.